This is question 6 for the AQA GCSE Physics June 2015 Unit 2 question paper. On screen now is the mark scheme for the question, so please mark your work. Because the question is quite a long one, the mark scheme has been split over two sides, so you may wish to pause the recording now so you can mark 6A I to 6B part 3, and the rest of the question will be shown on the next slide. Here's the last part of the question 6 mark scheme, so you can use this to finish off marking your work. Once you've finished marking your work, if you've got the question correct, I suggest you move on. If you get parts of the question incorrect, please listen to the rest of the recording so you can find out how to answer the question correctly in the future. So for the first part of the question, it says Figure 7 shows the forces acting on a model air-powered rocket just after it has been launched vertically upwards. You can see the direction of movement is going up. We've got air resistance which is acting down and also weight that's acting down. It says how does the velocity of the rocket change as the rocket moves upwards? So if the rocket's moving upwards but the only forces on it are acting down, that means the resultant force is acting downwards, which is in the opposite direction of to the direction of movement, which means that the velocity is going to decrease and it's going to go all the way to 0 until it'll stop, and that'll become negative, won't it? So it decreases to 0. That will be 1 mark. And then asks you to give a reason for your answer, and that's because the resultant force acts downwards or against the direction of movement. I'm going to put downwards in this case. So it's acting in the opposite direction to the direction of motion. Next part of the question, 6A part 2, so the velocity of the rocket is not the same as the speed of the rocket. What is the difference between the velocity of an object and the speed of an object? To answer that question, the idea is that velocity is speed in a given direction. So the velocity depends on the direction of the object as well as its speed. That will get you the next mark. To answer that question as well, you could have also had the velocity as a vector, because that means it has a directional component. In 6 part B, you're given that the speed of the rocket just after being launched is 12 meters per second. So you know that V equals 12 meters per second, and the mass of the rocket is 0.05 grams. Kilograms, that is. Right, so calculate the kinetic energy of the rocket just after being launched using the correct equation from the physics equation sheet. So you should find that KE, kinetic energy, is equal to 1/2 times m times v squared. You should find that off the equation sheet. Putting the numbers in, we get 1/2 times 0.05 times 12 squared. You must remember to do the 12 squared first. That comes out with an answer of 3.6 joules. 1 mark for that bit there, and 1 mark for that bit there. Please notice the 0.6, 3.6. 6BII says, as the rocket moves upwards, it gains gravitational potential energy. State the maximum gravitational potential energy gained by a rocket if you ignore the effects of air resistance. You'll know that the conservation of energy law states that the energy cannot be created or destroyed, it can only be transferred, and so that the kinetic energy is all going to be transferred into gravitational potential energy because you've got no air resistance. So that will be the same answer, 3.6. Okay, if you get the first part of the question wrong, you want in your answer written here to be the same as the one above, and you get that mark. The next part of the question says calculate the maximum height of the rocket will reach, ignore the effects of air resistance, and it gives you that gravitational field strength is 10 newtons per kilogram. I want you to use the correct equation from the physics equation sheet. So on our previous equation, we worked out that gravitational potential energy was equal to 3.6 joules. We were also given that the mass was equal to 0.05 kg. You're also given velocity, but we don't need that for this part of the question. Using your equation sheet, you're going to find out that GPE is equal to M times G times H. So we can put the numbers in there to get 3.6 equals 0.05 times by 10 multiplied by H. That's 1 mark. Rearranging gives us that H is equal to 3.6 divided by 0.05 times 10 in brackets. That gives an answer of 7.2. So we can put that into the correct box there. And 7.2 is our maximum height reached. Again, the correct answer is the second mark. 6b part 4 shows that it says figure 8 shows 4 velocity time graphs A, B, C and D. It says taking air resistance into account, which graph A, B, C or D shows how the velocity of the rocket changes as it falls from a maximum height it reached until it just hits the ground. So looking at the graphs, we have A, we see that V decreases. In part B, V is increasing, but the rate of increase gets less with time. Part C is showing that V increases and the rate of increase increases with time. And finally, part D is showing that V stays the same. So what's going to happen as the aircraft or the rocket falls from a maximum height? At first its velocity will begin to increase, so it's got to be B or C. But as its velocity increases, it's going to collide with more particles. So as it collides with more particles, the rate of increase of velocity will decrease, therefore, until it reaches its terminal velocity. And we're going at a constant speed. And the graph that's showing us velocity increasing until a maximum is graph B. So B is the correct answer. In part C of question 6, it says a rocket can be launched at different angles to the horizontal. The horizontal distance the rocket travels is called the range. Figure 9 shows the path taken by the rocket when launched at different angles. Air distance has been ignored, so I'm just going to make figure 9 larger, so you can see it better. So that's figure 9 there. Put up that bit there. It then says what pattern links the angle at which the rocket is launched and the range of the rocket. This is quite tricky because there's two parts to the pattern. At first we can see that as the angle increases from 20 to 30 and then to 45, the range increases. But then you'll notice that as the angle increases from 45 to 60 and then 60 to 70, the range decreases. So that's the information that we need to get across in our answer. So here he's saying as the angle increases, the range increases until the angle of 45. There'll be 1 mark the fact that the range increases until an angle of 45 is reached. The second mark is for saying that after 45 degrees as the angle increases, the range decreases. And that is the second mark to that question. And that brings us to the end of the question. on the end of the paper. Thank you for listening.